Well, good morning, and again, here we are talking about algebraic transformations. Let me turn down police just a little bit. And we are looking at today the algebraic means by which we can manipulate the geometry called a vertical compression or a vertical shift. So again, we're going to start with that parabola or the quadratic function that we have been so familiarly working with. Again, the parent graph looks something like this, y equal x squared. And so we're going to say, hey, if we wanted to take that vertically and we wanted to maybe grab the top and grab the bottom of that particular quadratic function, and we were to simply stretch it, pull it higher. How would we do that? If we wanted to do that geometrically in our artwork, how would we accomplish that in our with the algebra and being able to do that? So again, we've added things, and we learned yesterday that, or in the earlier lesson, that that we if we add things to the parent graph, if we add things to the function itself, then it shifts it vertically up and down. If we add something negative, it's down. Add something positive, it's up, and that makes sense, doesn't it? So today we say, well, if it's not adding, what could we do? Well, we really have multiplying or dividing, and multiplying is division, or division is multiplying. It's just by the inverse. And so what we can do then is take that and say, well, what would happen if we took that parent graph, x squared, and we multiplied it? Not x squared plus, but something times it. Again, in our quadratic functions we started in the fall, that's the a. If we make a larger than 1, which is what it is in the parent graph, what effect does that have geometrically to the graph? So I'm going to hold the calculator up here, and I'm going to try to hit the graph key for you so that you see these two graphs. And the parent graph will come up first. Don't have the axis up from yesterday. And then there is the 3. So what effect did it have? It looks skinnier, right? Just got through the holidays, and it went on Jenny Craig. Yeah, I said it needed to. It felt like it needed to. It needed to lose some weight, get a little thinner, get a little skinnier. And sure enough, the Jenny Craig effect did have that skinniness or that thinness appearance to the geometry. That looks like again, you could accomplish that, but hey, well, Stevenson, how come it didn't do this? How come you didn't get a hold of the side to side and squeeze it forward? Because it kind of looks the same way, and you're absolutely right. The effect on the geometry of vertically stretching is the same effect as if you were horizontally compressing, and we're going to talk about that and how to do that algebraically as well. But the effect of the geometry kind of looks the same, and it's hard to tell the difference between the two when you're just looking at the geometry. So, but the algebra is clear. So this is vertical stuff, and so this is a vertical stretch. Well, let's see. And that would make it taller, or it made it skinnier, right? So what would we do to? I'm going to turn the axis back on here. What would we do to the algebra to get it to be wider, or in essence having the effect geometrically of taking the top and the bottom of the function and squeezing it, or what we say is compress that function, compress that papa, that parent graph down, that x squared. So if that's what we wanted to do in our artwork, how would we accomplish that by with the algebra? Well, we multiply again to get a vertical compression, but what we do is we multiply not something by larger than 1, but we multiply by something between 0 and 1. Well, these are fractions, 1/2, 1/4, 3/4, or decimals that are between 0 and 1, 0.5, 0.3, 0.2, 0.1, and those kind of things that we can do. And so what I'm doing is typing into the parent graph, again noticing that the algebra, all the parent graphs are in the same family. They're all x squared. But now we've got the parent graph on the top, x squared, in that first function. And then we've got the 3 times that parent graph. That made it taller, skinnier. It stretched it because it was larger than 1. And then the 0.5, let's see what effect that has on the geometry. So there comes Papa. There's the stretch. And sure enough, there's the compression. It got wider. And again, we can make that even, we can keep adding artwork to it. If I wanted to make it wider, I would just make a number closer to 0. So again, closer to 0 than half is 1/10 or 0.1. And so we're going to graph that and see how much wider it gets. And so those are things that we're learning. So that's another transformation. It's a vertical thing. We've been talking vertical. We're 5 minutes into this video of how to do things vertically, how to stretch them and compress them by multiplying. Multiplying larger than 1 stretches vertically. Multiplying between 0 and 1 compresses or makes it wider, makes the geometry in the picture look wider than Papa did when it wasn't messed with. Okay. Again, hey, you're getting closer every time we visit together. You're getting stronger in being able to create your artwork that you have there algebraically and see that art taking shape. All right. Thanks. See you later.